we are going to learn another basic topic in coordinate geometry, that is transformation of axes. We have looked into polar and Cartesian coordinate system. We solved these problems. The second topic was distance formula. So initial all these topics are basic only unless we start the straight line and further topics. So there are two sections of this video. First one is shifting of origin, another one is rotation of axis. So what is the need of doing all these things? Some of the problems become simpler when you change origin or when you rotate the axis, x and y axis. We will see both of the sections. There are total 7 problems in this tutorial, and let's start with shifting of origin. Origin is the point where everything starts, and that is the comparison point, right? Any number is compared against origin, because in default coordinate system origin is 0 0. When you say 2 3, this is compared against origin. So if you change this origin, your comparison point is changing, right? So your coordinates will also change. Suppose this is my default x and y axis. This point is origin 0 0. There was some point x and y. So the meaning of xy is the horizontal distance is x and vertical distance is y. Now if I change the reference point, if I change this reference point from where the comparison is getting done, let's say we are changing it to this point, we have shifted this origin h in this direction, x axis, and k in y axis. So obviously these are variables, and when you're changing this axis, you need to use another variable. In the books, either this is x dash or capital X. I am going to use capital X. You can use any other variable. Now since this origin is changed, this coordinate, the value of this x and y will also change, right? We will say x and y. So what are these values? These are basic arithmetic. You don't need to remember anything for solving any of the problem. So for this new coordinate system, the horizontal distance is this much, which is obviously x minus h, right? X minus h. We will say x is this, and this vertical distance with respect to this, the comparison point is changing, right? This is y minus, this is y, right? So this is y minus k. So we got two equations. You don't need to remember. If you can remember, it's fine, but no need to remember. If you change it, x will become x plus h and y is y plus h. So there will be problems which will ask about change in the coordinates, change in the equation, change in the new coordinate system. Sometime equation in the new coordinate system will be given. You have to find equation in the old coordinate system. Sometime the point in new coordinate system will be given. You'll have to find coordinate in the original coordinate system. The first question: at what point should the origin be shifted if coordinate of a point 2 3 becomes -5 -7? Okay, so first question, you can try solving it. So point is 2 3. New point is given in the new coordinate system, that is -5 and -7. Before solving, just think about it, right? If you have this default coordinate system with 2 and 3, where should I shift this origin? Here, 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 here. Obviously it has to shift somewhere. It has to shift somewhere around this side, right? Then only from that coordinate system, this point will be coming in third quadrant, right? 1 2 3 4, where x and y both will be negative. Okay, another way to remember this, right? Although you don't need to remember, but to remember it, x minus h, why we are subtracting? Because this is first quadrant, right? In this example, just how to remember, this is the way. When you're shifting this comparison point, right, your x axis, this distance is, in this example, is shorter, right? You are short by h, right? X minus h, and here y minus k. It is reachable quickly compared to this system, right? This is shorter. So that's why this is negative, x minus h, y minus k. So this is xy, right? This is xy coordinate system. This is another variable x and y, and this is x and y. So x is x minus what point? We don't know, right? H and k, we don't know. X minus h, and y is, or before y, let's solve it, right? X and y, we have both these things. Negative 5 is 2 minus h, so h is 7. Y is small y minus k. Negative 7 is 3 minus k, so k is 3 plus 7 is 10. Origin should be shifted at 7 and 10, that is h and k, and this is the answer. We'll move to second question. If the origin is shifted to the point 1 1 without any rotation of axes, what does the equation become? It says origin is shifted to some point 1 and 1. This is my new origin, x y x y, and equation is given in this coordinate system. X square plus y square is 25. If you're not aware, this is the equation of circle. Alright, so circle will be somewhere here with 5 radius, right? It will be like this. When you shift this origin, everything is changing, right? The points are changing, the equations are changing. So we are basically, origin is reference point. So how to solve this? You have to basically find this equation in terms of capital X and Y, right? Every point is x, y, and we need to find equation in this variable, not, sorry, this was x, this x and y. So what to do? That, you know, x is x minus h, right? Or x is x plus h, y is y minus k, or y is y plus k, right? You have to just substitute here. What is h and k? It's already given, right? So this is x plus 1 and y plus 1. You have to just substitute. This becomes x plus 1 whole square plus, this is 25. You can take this out. You can expand it also. X square plus 1 plus 2x plus y square plus 1 plus 2y, or x square plus 2x plus y square plus 2y is 1 and 1, so this is 23. But generally when we transform this x and y, capital X and y, small x, y, doesn't matter, right? Your equation, ultimately equation will be x square plus small x plus y square plus 2y is 23. When you write this x and y is with respect to new coordinate system. You could have written it like p square plus 2 z square plus something like that. You can do anything. These are just variables. Moving to third question. It says the equation of a curve refer to the new axes which are parallel to original axis and origin as 1 2. Alright, so the origin is already shifted, is x square plus y square is 25. This means the equation is given in new coordinate system which has origin 1 and 2. So find the equation refer to the original axis. Original axis is default axis with 0 as origin. Let's solve it. So now we have equation in capital X and Y, right? New coordinate system. So here x square plus y square is 25 is given. X, y, equation with respect to this coordinate system is given. So x is x minus h. H is already given 1 and 2, right? This origin is 1 and 2. Always visualize, okay? Don't remember x minus h, x plus h, right? So x is x minus 1 and y is y minus 2, and we need to just substitute and we are done. plus y minus 2 square is 25. You can expand it. X square plus 1 minus 2x plus y square plus 4 minus 4y is 25. How much we have? 5. This will become 20, right? So x square plus minus 2x plus y square minus 4y is 20. This is the answer. Last question on shifting of origin. This is the most important question. If you do it rightly, you'll solve it very quickly. But if you go lengthy way, there are two ways to solve it. Let's try to solve. A point Q, -2, -1 lies on a circle x square plus 4x plus y square minus 10y minus 7 equals 0. By translation of origin to a certain point hk, the translated equation of the circle becomes this. Find a new coordinate of point Q. So now in this we have two coordinates to compare with. The original coordinate where origin is 0, 0. In fact, let me tell you, you don't need to remember. If you know the concept, right? Not necessarily you have to do with coordinate system with 0, 0 and compare with something else, right? You can compare two coordinate system where the points are non-zero. Like this is -2, -2. This is 2 and 2. You can compare equations in this. You can transform equations from one coordinate system, different origin, non-zero origin, and you can solve those problems also. Coming to this question again, the equations are given in the original axis and new axis. Those are given, and how to solve this? Let's think on this. So equation is x square plus 4x plus y square. You also try to solve parallelly. If you can't do it, I'm with you. You can check the answer. That is the right way to learn. Alright, another observation. If you see these all exercise, you might have noticed something here, right? You see x minus 1, y minus 2, and where is that? X plus 1, y plus 1. These things keeps happening, right? So to leverage that information, can we transform this equation with something like this, x plus something like x plus 2 square or x minus 2, y plus 5, so that we can compare this with this equation. Okay, how to do that? Let's try to solve. Is this not something like x square plus something x plus 2, right? X plus 2 whole square. Obviously you're adding 4, so subtract 4, plus this is 5 times 2, so y minus 5 whole square. You are adding 25, to subtract 25, minus 7 equals 0. X plus 2 whole square plus y minus 5 square equals 25, 29, 36. And if you compare from this transformed equation, x square plus y square is 26. This is actually x square, capital X square plus capital Y square, and the reference is those translated axes, right? So we have to compare with this. X square plus y square is 36, and what do you see here? X is x plus 2 and y is y minus 5. And if you remember that this is by how much we shift it, right? This is actually x minus h, this is y minus k, so h and k becomes, this is negative, so this will be -2 and 5. So this is the point where we are shifting, right? We are just transforming this this equation into something new variable, where you have the relation between with that variable, and by shifting something, right? X plus y minus y plus, this could have been y plus also. In that case k will be -5, right? You have to find this kind of, if this is easy to do, you can do it this way. I hope this was not confusing. You have to just transform into some plus and minus and create another variable and compare with the equation. So x square plus y square 36. So h and k is shifted to this point, negative 2, 5. And in the question, one point was given negative 2, negative 1. Okay, negative 2 and negative 1. So you have to shift by, origin itself is shifted by this point. So you have to, what? You have to subtract it, right? Minus 2 will be plus. So this will be 0, and negative 1, negative 5 is negative 6. So this point will become 0 and negative 6. You can do it formally also. This is what? This is hk. This is new origin. Negative 2, 1 is xy, right? In the original coordinate system, this is xy. You have to find capital X, right? So this is x plus 2, right? This is x plus 2. So negative plus 0. Y is what? Y minus 5. Y is negative 1, negative 5, negative 6. Okay? This is the logic here you have to apply. There is another formal way to do it that also you can try, but that is little bit lengthy in calculation. The equation was x square plus 4x plus y square minus 10y minus 7 is 0. This is in this with respect to these axes. And we don't know where this origin will be shifted, but there are set of x and y axes on which equation is like this: x square plus y square is 36, right? These two equations are given. Actually this is x square plus y square is 36, right? When you change the equation, the reference point is also changing. All right, so you write like this. You have to change from this to this, and we know this is x minus h, y minus k, or if we take this side, x is capital X plus h, so just substitute it, x plus h whole square plus 4. I'm not going to do the calculation. You can try. This is not hard, easy to do, but I'm leaving it to you. Y plus k, negative 7, 0. So this is very easy to do, right? You will have x squares term, some coefficient will be there, then x, some coefficient will be there, y square, some coefficient will be there, and then y, there will be some coefficient. And if you see this equation, there is no x and y, right? If there is no x and y, you just make this coefficient as 0, this as 0, you will get the value of h and k. And what is h and k? This is new origin. You should get it, if you do the calculation correctly, you should get it as negative 2 and 5. But this is little bit lengthy. If you can't do this way, obviously this is the last way to solve it. With that question, we are done with the shifting of origin concepts and question, and hopefully you will be able to solve any of the question related to shifting of origin. Now let's see rotation of axes. The meaning of rotation of axis means you have this x and y, and you are shifting this reference point. Axes are also reference point, right? Origin is not good enough unless you have axis. So you are shifting it to some angle theta. Obviously this will be perpendicular to that. There are some point x and y. Obviously when you are dealing with rotation of something, always better to deal in polar coordinate, not in Cartesian. Cartesian you can do it, it will be little bit lengthy in calculation, but ultimately there are both ways to solve it, this problem. What are we trying to solve here? We are seeing the effect of rotation of this axis on existing coordinates in this original axis, right? And we will also see how to transform any equation from this default coordinate system to this rotated coordinate system. So this is theta, and let's say this is the point. If this is the point, suppose this is r length, all right, and this angle we don't know, but we can define some angle here. Let's define this as alpha. So this in polar coordinate system, this will be r and alpha, r length and the angle with respect to this original axis r and alpha. In this new transform, let's make it like that only, x and y. With respect to this new axis, the angle is what? Alpha minus theta. In this x and y, small x and y coordinate system, what is the value of x? X is r and this angle, right? Alpha. So x cos alpha, r cos alpha, and y is r sin alpha. Simple, right? Now in this coordinate system, x and y, rotated axis, the value of x will be r cos of what angle? Cos of this angle. This is my reference point, right? This is reference point, this and this. So this angle we need to see. In the original coordinate system, we were seeing this value alpha. Now this is alpha minus theta, and y is r sin alpha minus theta. Just expand it and put this value, you will get the relation, right? So x will be r cos alpha cos theta, this is negative, so positive r sin alpha and sin theta. This will be r cos alpha, you already know, x cos theta plus r sin alpha is y sin theta. So this relation we have now, x is x cos theta plus y sin theta. Similarly, y will be what? Y is r sin alpha minus theta. So this will be r sin alpha cos theta minus r cos alpha sin theta, right? And r sin alpha is given, so this is x cos theta minus y sin theta. No, so this will be no. So r, okay, so this r sin alpha is, this is y, this is x. So another relation, we have another relation. If we write it very neatly, this becomes x cos theta plus y sin theta, and y is negative of x sin theta plus y cos theta. This is one relation. You can find capital X in terms of x also by some manipulation, like if you make this cos square sin square and cos square theta plus sin square theta is 1, right? So you can do the reverse way also. For example, if you multiply x cos theta in this will become what? X cos square theta plus y sin theta into cos theta. And if you multiply this is x cos square theta, so you can make it sin square theta, right? So negative x sin square theta plus y cos theta into sin theta, just subtract, plus minus, this will become 1, right? And this will cancel out, so x is x cos theta minus y sin theta. Similarly, you can do other way also. If you multiply here sin theta, this will become sin square theta, and you will get y. Y is x sin theta plus y cos theta. These are not very easy to remember, so there is a shortcut way to do it. Okay, I have not invented it. This is the way it has been followed so far in books. Cos theta, this is sin theta, negative sin theta, and cos theta. Alright, if you have to find anything like y is what in terms of x? X minus sin theta plus y cos theta, right? If you find this x, this will be x is caps x cos theta minus y sin theta. Moving to first question, a new coordinate system is built by rotating the axis by pi over 3, 60 degree in anti-clockwise direction with respect to 0, 0, the default coordinate system, origin of default coordinate system. Find the coordinate of point 24 in new coordinate system. So this is just application of this formula, right? What is given here? Theta is given pi over 3, right? 60 degree. And what else is given? X, Y is given 2 and 4. You have to find capital X and Y, right? Because that is the coordinate that will be this one, right? Shifting by pi over 3. With respect to this and this, you have to find the coordinate of 2 and 4. So X is X cos theta plus Y sin theta, right? So X is 2 cos 60 degree plus Y sin 60 degree. These are all easy. 2 over 2 plus Y. So this becomes 1 plus 2 root 3. This is the coordinate, X coordinate in this coordinate system. Y is what? Negative X sin theta plus Y cos theta. Since we are starting, right, so I'm just trying to give one basic question before we move to little bit tough. 2 4 cos 60 degree, you can solve it. So this will be negative 2, so root 3 plus 4 by 2 is 2. So the new coordinate will be 1 plus 2 root 3 and root 3 plus 2. Let's move to next question. The first question was with respect to point. Now second question deals with one equation. The equation of a curve is 3x square plus 2xy plus 3y square equals 10. Find its equation if the axes are rotated about the origin through an angle 45 degree. So equation is given in this coordinate system, 3x square plus 2xy plus 3y square is 10. And what is the relation? The relation is already given. Theta is 45 degrees. So we already know what is the relation of x and capital X, right? X is cos theta minus y sin theta. Cos 45 is x over root 2 minus y over root 2. And y is x sin theta. Why we are using this, not the other way? Because we have to substitute and find the equation in new coordinate system with variables x and y, these axes. X sin theta plus y cos theta. So this will be x over root 2 plus y over root 2. And now we are done. We have to just substitute here these x and y and find the equation. Let's substitute. 3x square, so this will be 3 over 2 x minus y, right? X minus y square plus 2xy, so this will be 2 over 2, right? This will be 1. And x minus y, x plus y, so x square minus y square plus 3y square, so 3 by 2, right? Root 2 square is 2, 3 by 2. X plus y square is 10. If you solve this, finally you will get 2x square plus y square is 5. I'm just skipping in between these steps. You can solve it. The answer is 2x square plus y square equals 5. Last question of this video. If the axes are rotated by tan inverse 3, then find the transformed equation of y equals x. What is given here? Tan theta is given, and we have to find the transformed equation of y equals x. So theta is given. Theta is tan inverse 3, right? That means tan theta is given 3. By this angle we are rotating the axis around origin. So x is equation is y equals x, and in terms of variable of new coordinate system with respect to new axis, this will be x sin theta. Y, I'm just substituting here, x sin theta plus y cos theta equals x is what? X cos theta minus y sin theta. Okay, and what is given here? Tan theta. Actually, you can do like this, right? You can 3 1 and this will be root 10, right? You can use this tan theta and find sin theta, cos theta. You can substitute it also, but here if you look this pattern, right, you just divide it by cos theta, everything will come in tan theta, right? So this is x tan theta plus y equals x minus y tan theta. Tan theta is already given 3, right? 3x plus y is x minus 3y. So this will be 2x equals y minus 4y, or x equals negative 2y. So x equals negative 2y, or y equals negative x over 2. This is the answer. That was the last question of rotation of axis, and hopefully you will be able to solve any of the question related to these topics. We will meet again with a new topic and see you soon. Bye.